All right, this is questions 15 through 19. Solve the inequality and express the answer in interval notation. So number 15, we want to isolate x, okay? And we have to just be careful with inequalities because when you get down to the last step of solving, you're either going to be dividing something off or multiplying. If that coefficient in front of x is negative, then you divide it off regularly. However, the inequality sign will change. And we're going to see this with number 15. So 3 negative 2x is less than or equal to 11. So the first things first is I want to isolate x. So I'm going to subtract 3 off of both sides. So negative 2x is less than or equal to 11 minus 3, which is 8. Now, I have a negative coefficient of x. This is what I'm talking about. In this final step, to get x by itself, I'm going to divide by negative 2 to both sides, but I'm going to change my inequality sign to face the other way. So it's going to be greater than or equal to. So I have x is greater than or equal to 8 divided by negative 2, which is negative 4. Now, this says that all my x values are bigger than or equal to negative 4. So negative 4 is the smallest one. And in interval notation, I get negative 4 going to infinity. Number 16, isolate x. That's what we have to do. So we have negative 2x minus 4 is greater than x plus 5. So I'm going to subtract x off of both sides because I'm trying to get my x on my left-hand side. And the reason why I'm trying to do that, it makes life much easier to write things in interval notation. So negative 2x minus x will give me negative 3x. Negative 4 minus 5 will give me negative 9. And that's greater than 0. Okay? Now I'm going to add 9 to both sides. And by the way, I could have left the 5 there and just pulled the 4 over, but I did this a little bit longer. So negative 3x is negative 3x is greater than 9. Again, I'm on my last step of isolating x and I have a negative coefficient. So I'm going to divide off the negative 3 like I normally would. And then I'm going to change the inequality sign's direction. So it becomes less than. Okay? So now I have x is less than 9 divided by negative 3, which is negative 3. So if I write this up, it says all my x values are smaller than negative 3. So I have negative infinity going to negative 3, but not including it. Okay, number 17. Now we have an inequality where I have two inequalities and both of them are less than, and one of them is equal to as well, but still. So I can solve this simultaneously by isolating x. So I'm going to subtract 1 off of all sides. So negative 3 minus 1 is negative 4, is less than 2x, which is less than or equal to 2. My next step is to get x by itself. So negative 4 divided by 2 is less than 2 divided by 2x, which is less than or equal to 2 divided by 2. So negative 4 divided by 2 is negative 2, is less than x, which is less than or equal to 1. If I write this up in interval notation, negative 2 is my smallest value. And remember, it's soft parentheses because there's no equal sign. And it's going to positive 1, which is included because there's an equal sign in that inequality. So negative 2 to positive 1 would be my solution set for number 17. I'm going to stop here, and then I'll make another video to cover 18 and 19 and maybe 20, but we'll see. Okay, so thanks for watching questions number 15 through 17.